And then at runtime, it's releasing check. So the worst case you have to do is add the data.
The cross compiling is a problem.
Yeah, like I was saying, I don't think it would be difficult to add an amalgamation target, and maybe even strip out some
Yeah,
stuff you don't want. I mean, if you could
because
specify,
I couldn't have all the time zone data. That would be hard to put
you
in
specify what it is
amalgamation.
you want, which species you want to move out of the data.
Hard to say.
Well, the other thing is,
No, that's good. That was smart.
Well, Steve has some idea of maybe doing something else, but who knows?
pretty real.
Yeah, well, unfortunately, yeah.
Yeah.
It may just work. And if it just works, I think that's a very low hurdle way to get people like distributed. It might not meet everyone's definition of what in the core means.
What slash packages is regular packages.
I would say
Also can do so.
And then the other thing is,
It would be great to have a TDBC backend.
that would offer another back end.
well, and
TDBC is kind of strange.
I know that TDBC.
It's all harness and no horse.
And I know that the script level TDBC SQLite wrapper does just build when it dropped in there, because I tried that. And I think what we really need is to, I'm trying to figure out what the best way forward is in series of uniformity type design. SQLite was, SQLite.
Can you show me your badges?
Not designed for multiple customers.
SQL was designed for SQL tests, whereas the other databases were not.
This is video footage, you know, not only photos but the video.
Also do the area charts.
I had to generalize that to declaring parameters.
The stuff that's configurable as well, you change fonts and stuff.
Yeah, I think just about everything is configurable in there. I've got a little graphic.
Scott, where is your badge? Don't you have one? Oh, just must film it. Great. Thanks.
Is this all going to be posted on the web?
Oh, I will distribute it on between us, I think. I will put it on my server. I'll give you a link.
And in a lot of time, they want to pull the part of the spine out and very carefully, go in and analyze. I'm thinking, after I saw what you guys had, I would just freeze this thing, or I would just go through the shavings, seeds and all, and everything, and you have it, and you could recreate it with, you wouldn't get the annotation.
Why is it? We're only dealing with
I care about one thing. Oh no, it's not like I care about 3,000 rats. I do that because outer one thing I do on a large
Oh, let's look at bucklers.
I like to film you with your badges. Golly, don't move so fast. Yeah.
Can you film me getting coffee?
Oh, a coffee? Okay. Just feel natural.
I know do tap in, but I don't do that one.
So they now have
Terry, can I have your badge? Oh, I would like to film you. So everybody will be live on Santa Clara. That's right. Silicon Valley.
My retrieve. Dollar script.
It just makes my life a little bit easier.
That's compact, so it's really only 2 4. That is not that much of a performance burden. And that gets it threaded through the NRE stuff free for nothing. And I started looking at reworking the for each calls at sea level with NRE. And I said, no, this is not worth it. Maybe Miguel can do it, but I can't. And I have NRE enabled tickle commands because I needed an NRE switch and it didn't work.
Do those bodies end up getting bytecode compiled at all, or is it just...
Those bodies do get bytecode compiled because Miguel is compiling up levels. And he's even worked out a way so that when he compiles up levels, the first time a variable gets resolved, the resolution gets cached. So you even get the benefits of the local variable table in the up-leveled code. Extremely tricky. But yes, yields inside DB eval works.
And we had lots of checks because of the state data sets and info. So, and function renaming made debugging very tough. We don't have good debuggers in Tcl, so puts can help you as much only. And with puts, the debug messages were very complicated because we had to store the current data set, the current view. So messages, the logging became very complex. So what to do? We figured out that the bottom line of these all problems is basically variables located in global scope, functions are renamed, and there was a restricted data set. Basically, checks because of the restricted data set. So, if you think in terms of OOPS concept, variables in global scope, since they were attached to a data set, they could have been actually encapsulated inside the data set object, had there been one. Then function renaming is basically, had we had a common data set base, we could have inherited into different types of data set objects, avoided function renaming, so we could use polymorphism. And similarly, we could use inheritance to support the restricted data set. Since the whole GUI team is from a C++ background, the most obvious choice for us to was to use INT33. So that's what we did. And this is how we designed the new implementation, the new interface between the dataset sources and the new servers. So we put everything inside the dataset base class, the dataset name, the path, the list of windows attached to it, then the current view it is in, and various properties, whether you want to switch view or not, and all those the access functions and the methods and the variables. And from them, from this dataset base, we derived the class for the regular dataset, which is the dataset which had all the properties, the full suite basically, and the restricted dataset class, which had a limited set of properties. So since inheritance was used, so the base class had the default implementation of all the functions. So if a function was not, property was not there in the restricted dataset class, the base class function actually had us that it is not there, so it used to return false, whatever. Similarly, we attached the RTL view source and the netlist view source we had a local copy here. So again, the global access to these view servers was restricted. So each server knew that now it is communicating to which data set. So communication was more streamlined, and finally the results that after we released, shipped out our first release with the new implementation, we found that the code base was reduced by 15%. The incoming bug rate has been reducing ever since we made that release by 50% every month. And we started off with around 200 bugs, now we are down to 10. Then ever since the new release, no showstopper issues have been found, which were coming at the rate of probably 3 to 4 every month. So it's been there in the market for the last, I think 6 months. Now customers have been using it. So the whole re-architecture had been very impressive for us, and had Infratical not been there, I don't think how we could have done it, because the only other option would have been to rewrite the whole GUI, probably in Qt or some other thing, which would have been possibly a 2-year effort, probably more than that. And then we would not have, the incoming bug rate probably would have been still higher. So the lessons that we learned was, basically I think in this conference it has been stressed many times, that yesterday in tutorials also, that global namespace should not be polluted. So we should avoid using variables with dynamic. And the other thing that we figured out was to make debugging easier. We should not have dynamic names like the example which I showed, gadd, $ds1. So that makes debugging a bit difficult, searching for variable names inside the code. So if you have a legacy code to maintain, these things actually annoy you a lot. It makes reading code difficult. Then function renaming, basically, it is good. It's a good feature in Tcl, but we realized that how it can be abused, and it was abused really heavily in our code. So it's good for basically debugging purposes, but probably if you are using a production code, I would say we should avoid renaming functions. Then we also had, for all the menus, we had global variables. So after encapsulation, we put all the state variables for the menu inside the dataset object class. So again, this is the same thing as mentioned in the first point. And the issue with global, that list of windows, you should have, a dataset object should have its own list of windows. You should not have a global list of windows which says, okay, DS1 window 1, DS2 window 2, DS3 window 1, and all those things. It makes searching difficult, and you may miss out on adding a particular window to a global list when it was created as part of dataset object. So it's better to have window list encapsulated inside dataset object. The only global list now that we have after this is the list of datasets that are currently open, which is unavoidable. And use in particular if any of the above happen in code. So that's what. I think it was very short presentation. So any questions? Yeah.
What version of Infratical did you use?
I think 4.2.
Oh, so the latest one, that's the MLG version, right?
But not, no, it was not, no, it was 4, I think.
I would just version 4, Infratical was 3.2 in the current stable release, just to make things confusing.
And how many months did it take for you to convert your application from the global design to the new?
Took us 4 months, a 4-man team.
Was it better than what you expected?
Yeah, we never expected such good results. We thought that we would still have probably 100 bugs when we release the first version. We never got more than 50.
How do you track your bugs?
We have a ClearQuest database, so customers can log into those bugs.
Once you had everything encapsulated, did you find any? Did you notice that? Oh wow,
And any feature will be easier to add because oh, we can see what we're doing now? Or?
Yeah, definitely. So our marketing was very unhappy because the GUI was not stable, so we were not taking any new feature enhancement requests. But now that the GUI is stable and we know that the architecture, the new rewrite of the GUI actually helps us to add new features, even dataset specific features. It's easier for us and probably we can deliver them much faster than probably earlier.
Do you deploy in star packs, or do you have some other way in which you actually ship and deploy?
We have our own file.
Okay.
I know you said y'all from C++ is why you went with Inker. Did y'all look at any of the other object-oriented TICL extensions, such as Exotica or anything?
No.
Thank you.
Any other questions?
So I'm just curious how you sort of brought this thing up. Was it a big bang? Did you develop all these objects and then just shove them together? And in the course of this, is the new version more testable than the old? What sort of testing did you add?
Testing is basically on the GUI itself. So basically the front end never changed. Whatever was changed was the back end of the GUI. So there was no visible changes to the user. So our all existing tests were very much applicable to the new version.
The tests were manual?
A very small set of tests are manual. Majority are automated. We put in handles in our code so that we can run commands directly, TICL commands. We can directly execute our TICL functions with a given set of inputs, and that's how we test most of the functionality.
Did you find that there was any downside after you did the migration? Was there anything that you found more difficult?
I think not really. Yeah, not really, not till now. Like it's 6-7 months old, so maybe sometime later we may find some downside, but not till now.
Nobody complained then, right?
Nobody complained, yeah. And whatever new things that we have been doing are easy to do now in the new implementation, so we haven't seen any downside.
Any noticeable performance differences?
No. The GUI bring up time is still, I think, was very small earlier. Also, it's not like performance doesn't come into picture in the bring up time, so it's not there.
Thank you. Our next speaker is Ron Ward. Wolf. I'll let you say your name.
It's like old, but with a W first.
On Model Sim GUI.
Well, it's tough to last because I know that the only thing between all you guys and dinner is me, so I'll make this as quick as possible.
Ron, there's a correction from the floor over here. Apparently it's not dinner, it's drinks.
Okay, that makes it worse. All right, the title of this work is Too Many Windows. So you have a product, you have a couple of windows in it, and you start adding more and more and more. Is it scalable? What happens when that happens? This was something that crept up on the product I work on. I want to talk about some of the things we found, some of the issues, and how we dealt with them. Model Sim is it's a very successful application under MetaGraphics where it's like an IDE, and you basically, somebody that's designing an electric component will buy Model Sim, and you sit down and you write source code, you simulate it, and then you run it, you debug it, you analyze it, do a bunch of other things. The thing about Model Sim is it supports a lot of different HDLs. It's like 6 different languages in there. And as time's gone on, there's more concepts that are added to these languages. So we've added more and more windows. Right now, Model Sim has 53 actual windows in it. And I'll show you what that looks like. It's a little bit crazy. So what happens when the window count grew on us? It didn't happen immediately. It happened slowly. We started to see things like you'd hit the view pop-up menu, and it would take 3 seconds, and then it would display. Now, we're a tool that competes on performance, and when the dialog box or a menu comes up slowly, that, there's a perception of sluggishness there, and that's a real problem. With that many windows, we had inconsistencies, and they're really stupid ones. I mean, simple ones that, how did we miss that? Bugs, lots of bugs. That's a problem with it. And then this last one was really kind of a big one for me. When I got a phone call from somebody who's working on a menu item, and they got a PhD in computer science, and they can't get the menu item to enable or disable. All it is a state, right? We found ourselves in a tight spot there. Things were just taking too long to produce. And I'm going to give you a simple example one. This is just a little app. This happens to be our transcript window. And I want to add a menu pick delete. So how do I do it? There it is. Add command, label delete. And what to do, it calls transcript delete command. And by the way, I should have done this, but I didn't run these through the interpreter. So if you find a syntax error, you got to forgive me, all right? So that's all you got there. Now the next thing you want to do is you want that pick to enable and disable, right? I mean, if you can't delete right now, it should be grayed out, right? So what do you do? Well, you add a post command, and the post command calls a routine, and that routine, asks the transcript window, are you in a state, can you delete? If it's yeah, so we set it to normal, otherwise we set it to disable. It's simple enough, right? Okay, now, let's add a second window to it. Well, now that post command it just doubled in size. We have to add the notion of an active window, and our active window model is probably like any other TCL tool. We follow focus, and we know where the activation is, and we highlight it. You can see the blue bar up there. And the code says, well, if it's in the transcript window, I'll ask it if it can do it, set it. Otherwise, if it's the library, do the same thing. This nice and clean. It's easy to understand with 2 windows. But there's some more work you got to do too, right? Now you have when the user invokes that command, it's going to go to one location. You got to do the same sort of work there. Say, all right, if this was intended for the transcript, call the transcript delete command. Otherwise, call the library delete command. All right, now let's add 10 picks to each menu. Let's add 10 menus. Start considering undocked menus. This is a window that's been undocked. It's got a menu bar too. It's not the same code as that other code I was just showing you. That one was for the main window. Consider toolbars and pop-ups. Global key bindings, if F3 does delete, for say, anything, that's got the same problem. And that'll add 50 windows. And we found we had thousands of lines of code. All it did was enable and disable menu picks. And it was extremely difficult to add a new window, right? Going back to the new development window, when you have that many windows, I didn't write them all, and I worked with Brian, and he didn't write them all. We have a lot of people that come in, they have the knowledge about one window, they know the contents really well, they don't know how to add a window. And if they don't know about F3, and they don't go to the code that implements the key binding for F3, they just produce a bug by not doing something, because F3 doesn't work in their window. A lot of situations like that. So the hardest part here was understanding what went wrong, because we're doing this just like the examples in the book. I mean, this was normal, correct code. Why is it not scalable? Well, here's what we found. Every place a command can initiate from has to ask 3 questions. It needs to know, does this window, this active window, does it support the command? Can it do it right now? And it needs to know how to tell it to do it. So what do we do? Well, at one time I worked on Windows, and I know I just dropped in your respect meter for saying that, but Windows has a thing called a messaging system. And we stole that idea. We needed a way to have a command not have to know anything about the window it's going to send it to. It needs to be able to send it without, every time you add a new window, you got to have a new case entry for it. We came up with this idea of writing a system that, we call it VCOP. It's a traffic cop. It directs traffic, which are commands, to locations, which are windows. That's all it does. It knows how to do that, and it tracks the active window as well. The other key piece to this was an action table, and that's a term that we made up. Really, what an action table is it's just a procedure, and it has a standard form. And any window on our tool that wants to interact with the menu bar has to define an action table, and they have to tell VCOP about it. They have to register it. In the case I was showing before with the delete, there's a can delete in there. That just says, yes, I can, no, I can't. And there's the delete command itself. What happens when you do this is now where you had this massive post command that would know how to query the window. You just have one line of code. VCOP, can I delete right now? Cleans it up dramatically. Pardon me. Sorry about that. Okay, so here's how it works. You have a command from the transcript, you type it in, it goes to VCOP, and whatever is at the active window, it's going to wind up in the location in the action table and invoke it. Menu pick, same thing. It goes through the same code. Toolbar, same thing. Key binding, same thing. All the places that a command can initiate from wind up in the same spot. And the cool thing about this is can delete is coded in one and only one location. And so if we have a problem with a menu pick, I know right where to go. I know it's defined in one spot, not in 17 different places across the tool. Let me go back. One other thing about this. Now, when we have a new developer come in and they want to add a new window, some new concept, and they want to know how to do it, all I do is say, just code up your action table, register it with VCOP, and guess what? It interacts with all the menus. It's so much easier to do. A couple other features. I'm sorry. Menu system layer. The menu system itself, we put a layer above the intrinsic TK ones, and all you do now, we've hidden a lot of the details from the menu from these new developers. They don't see the guts underneath it. All they know is I want to add a menu, I give it a label, I give it the menu, I give it the invoke action, and I give it the can action. And that's it, we're done. That's all they need to know to get that menu pick to work. And this is another key piece. Our tool has a lot of third parties where they're going to source CCL code, and it's going to add 7 windows to our tool. It's kind of an add-on feature. There's at least 4 different groups that do this. There was no way they could tie in with our menus before we had the action table. To do so, they'd have to replace all the post commands, they'd have to replace all the bindings, they have to code all over the place to get that to work. Now, they're just like, excuse me, any other window. Just find an action table and register it. Okay, I'm going to move on to another one, menu items. And this one, Jeff was talking about this yesterday's talk. That quote up there comes from a book on GUI bloopers where don't change your menu picks. And I know this one firsthand because I bought my wife a laptop and I got her Word 2008 and I went to help her, and I'm used to 2003 and I couldn't find anything in this. I mean, I finally gave up after an hour and said, I'm just going to go use my old copy. And that's because they moved. I knew where they were at, and they moved, and they changed their names and all that. So as the window count grew, what did we do? Well, we decided to change all of our menu picks. We had to, because we have 50 windows. They all had 50 commands. You can't add that many picks to a menu. You can't have 50 things in a menu pick. In fact, I've read that the ideal number is around 7. Well, if we have 70 menu picks and 50 windows, we got to start overloading terminology. And another thing Jeffy said yesterday was it's easy to write a GUI. It's hard to write a good GUI. And this was probably one of the most difficult things we undertook. We had to take windows that use write, windows that use save, windows that use export, put. We had to combine all this stuff together and come up with one set of commands that made sense with all these different windows. Even though they were all doing something different, that was the charge. And in doing so, we won't change them again. We'll keep them stable. We won't have to because we have a good set of noun, verbs, and such. The other thing we did is review menu item changes. So we have, there's 3 people across the U.S. that are writing windows right now, and they're going to add them into our tool, and they're going to add a menu pick, and 6 people are going to swarm down on that menu pick and really analyze it. Do we really have to do that? Because that's where the problem starts. Once you start adding picks, if you're going to write a new window and you got new picks, where are you going to put them? Well, I know I would put them. I put them right at the top of the edit and the view because everybody's going to want to use my commands, right? It's my window, my commands are the best one, put them at the top. Well, that's where it starts failing. You really got to look at that, and you've got to follow every one of those changes. Review them. Another little trick we learned was, I call it partially dynamic menus. If you have a window that does write format and one that does, save data, you can only have one pick, and you need to have that pick in the right spot on that menu, and it should not change. And it needs to start with the same word each time. But I found that you can change the second word. So I can say, when the data one is selected, I can say save data. When the, format one, I can say save format. The user will go will naturally go right to it, they'll select it, and they won't have to rethink which window is active. If I change the first word, they will. It'll be confusing. So that's a little feature we've used to give them a little more detail on the pick so they're confident when they select it, it's going to do what they want. The last one is the active window menu. So we have a command called finite state machine inverter. Now I just made that up, but where in the world are you going to put that command? Well, there is no place to put it. So we had to come up with a way. Some of these windows are so unique that they don't match anything else. So we came up with this notion of the active window menu. At first, pardon me. At first, we were a little bit concerned about it because we are changing the menu. The way the active window menu works is when you activate a window, it's got the project active, the project suddenly takes over this menu pick. And underneath it are project-specific items. If I go over and click the objects, the same thing happens. The objects window takes over, and the object-specific ones are there. So for all the windows that really have unique commands, this is a way that they can get their commands on the menu bar. There's another feature or advantage to this, and that is if you've got 30 windows up, and you go to the main menu and you're going to do save, which window is that going to operate on? Well, the way you had to track it was you'd look for the window with the blue bar. That's the one that's active. That's the one that's going to be invoked on. If you got 30, it's going to take you a while to find it. But we found by putting that name up there, you could just glance right up and say, okay, I do have the project active. I'm confident my save is going to work on the project. Okay, this one's the layouts. The layout is how are your windows laid out? Spatially, which one's bigger, which one's smaller? Is it, a tab group, what have you? What we found is users have more windows, and the more windows you have, the more windows the user's going to have open at one time. I suppose it's kind of like somebody that sees a word processor the first time, and it's got 40 fonts, and they feel obliged to use 20 of them.